Google published a research paper that crashed memory chip stocks by billions of dollars. Micron alone lost 25 billion in market cap in 48 hours. The reason, they figured out how to run AI models using 6 times less memory, zero loss in quality. Now, you're probably thinking, cool tech news, it doesn't affect me. But it potentially does, because AI is changing how we work. And when AI gets cheaper and easier to run, here's what actually is going to happen to data analyst roles and people who are trying to break into the industry. First, I'm going to show you what happens with a 160-year-old economic principle called the Jevons paradox that explains why cheaper AI is going to create more analyst jobs, not fewer. Then I'll share my own daily work, what it looks like now versus 2 years ago, because the shift is already happening and it's not what most people are expecting. And last, one mistake I see career switchers making right now that's going to cost them if they don't fix it soon. I'm Jeff. I've been in healthcare analytics for over 13 years. I work as a business analyst consultant at a top Fortune 500 healthcare company. I use AI tools every day inside my work, build automations, reporting systems, AI powered workflows. So when I saw this paper drop, I didn't think about chip stocks. I thought about what it means for people trying to break into industry and also what it means for our industry and as data analysts and analysts in general moving forward. And on top of that, I'm on a mission to help 10,000 people break into data analytics. So if that's you, hit subscribe because I'll be sharing and updating you as AI evolves our market. So let's break this down. So the paper is called TurboQuant, and here's what it does in simple terms. When an AI model is running and generating responses, it keeps a working memory of everything that it's already processed. That working memory is called a KV cache. The longer the conversation, the the bigger the memory it gets, the more expensive it is to run. So if we look at this, before TurboQuant, AI working memory for the KV cache was about 16 bits per value. Now, after it with after TurboQuant, the same AI model working the same memory was reduced to 3 bits per value without a loss in quality. And what this means is that Google figured out how to compress that working memory from 16 bits down to 3 bits. That's a 6 times reduction. And what was the result? If you look at this, that means 6 times less memory used, 8 times faster operations, zero accuracy loss in all benchmarks. And they were thorough on the different benchmarks that they were testing. That is pretty insane. And this just means we're just going to keep getting better from here. That is up to 8 times faster also on certain operations. And that's not an incremental improvement. That changes the math on whether a company can afford to deploy AI at scale. And problems that were too costly now become viable. And those are the opportunities that we need to be looking at. It gets interesting for your career. And what we're going to do is we're going to look at how technology affected the world and how we had to evolve due to major technological advances. So back in 1865, there was a British economist named William Stanley Jevons that he noticed something that was counterintuitive. Steam engines were getting more efficient. Everyone assumed that it would reduce coal consumption. Less coal per engine, less coal overall needed, which makes sense, right? But what ended up happening, the opposite actually happened. Coal consumption exploded because when coal got cheaper to use, more factories adopted steam engines. New industries formed, new use cases emerged that nobody had anticipated before because it wasn't possible. The efficiency gains didn't shrink the market, it drastically expanded it. This became known as the Jevons paradox and has played over and over again. So let's go to a well-known machine that we don't really think about nowadays. Let's think about when ATMs first came out. Everyone thought that bank tellers would disappear. Instead, ATMs made it cheaper to open new branches. More branches actually opened. And with more bank branches, there was actually more bank tellers. ATMs didn't replace bank tellers. Now, let's go into what was a crisis back then when spreadsheets were first introduced in the 1980s. This is something that I've been in my research and in stories I've been reading. People legitimately thought that when spreadsheet accounting softwares like Excel were coming out, that it was going to revolutionize the whole industry and they were going to replace accountants and fewer accountants were going to be needed. So the thought was spreadsheets when it hits the market in the 1980s, more people predicted the end of accounting jobs. So here, what actually happened? The demand for financial analysts, accountants exploded because suddenly every department wanted data-driven financial insights. So then they needed accountants, they needed financial analysts, and it's this pattern that happens each and every time. So while we keep hearing that AI is going to replace jobs, which it will replace jobs, there's going to be new opportunities and new jobs that are created because of it, because there is the productivity and efficiency that we're going to gain is going to lead to new use cases that we never saw before. What's the most important thing is to stay up to date, to identify those opportunities and to make sure that you evolve with the market and not get left behind. So the thing to remember is AI gets 6 times cheaper. We're going to run into the same pattern. And my guess is the same one that's played out previously. Yes, there's going to be jobs that are replaced, but there's going to be new opportunities. So the question is not where will there be fewer analyst jobs? The better question is going to be how many departments that couldn't afford AI before are about to budget for it. And also, how many more departments are going to create software that they can't manage when AI they were able to vibe code all of these cool applications, but now when it comes to real maintenance and real work, how many of these departments are going to need analysts and people who can manage these applications with AI? Because I already see that happening with people who vibe code stuff who do not have any remote technical knowledge or foundations to be able to maintain the software or design it in a way that it scales and makes it easy for them to maintain. That is going to be the one of the new opportunities that I see personally, because as the cost of software development goes down, there's going to be so much more software that needs to be maintained because it's easy to create, but it's going to be hard to maintain and deploy. And also, knowing what type of software needs to be created in the right way is going to be a premium skill moving forward. And here's why I say that. In a March 2026 survey of 650 enterprise technology leaders, they found that 78% of companies have AI pilot programs that are running right now, but only 14% have scaled to production, those pilots to production. And in healthcare, AI in production, because healthcare lags, there's only 8% in production currently. So there's the opportunity in healthcare. Healthcare has the lowest production deployment rate of any major industry right now, 8%. And that's not because the technology doesn't work, it's because it's too expensive. So 47% is that it's expensive to run at scale. Almost half the healthcare organizations cite financial concerns as the top barrier to deploying AI. So think about what happens when the cost drops by 6 times. Those projects that were sitting on the shelf because the budget didn't make sense, those are going to start to get greenlit. Pilot programs that proved the concept but couldn't justify the infrastructure costs, now those move to production. Every single one of those deployments that needs people to understand the data, the domain, whether the AI output can be trusted, and to design AI systems that can keep maintaining and developing those applications and those programs, that's the opportunity that I see. That's the job. That's where the demand is going to be coming from. And if you're wondering that what trusting the output actually looks like, let me tell you what happened to me more recently. This is going to be a real use case, and it literally happened last week. I've been tracking my productivity data in detail. I've been using Toggle, highly recommend it. Go check it out. This is not a plug for that, but it's free and I've been using it. I track my hours, my output, my patterns, every single thing. I had AI analyze the full data set. So this is even when I take naps. This is my sleeping structure. This is when I go rock climb. This is when I build for the business, creating content, learning and upskilling with AI, and then building and doing various tasks. When I gave AI all the full data set, the raw data set, I wanted it to find trends and figure out what is my most optimal work schedule. It analyzed the data correctly. The math was correct. The trends it identified were real patterns that were in the numbers, but it got the conclusions wrong. It saw days where my output dropped and it attributed those low energy, poor sleep, working too much the previous day, and it gave it the wrong assumption of what was causing that. It started building recommendations around reducing my workload and adjusting my schedule based on these supposed low energy patterns. But the problem was it didn't have the full context. And this is why context engineering matters and making sure that your AI has the context behind it, because it will give you great recommendations, but based on not enough data. So when I went back and I looked at those low energy days, one of those days I had planned already, pre planned with my best friends to meet up and hang out. I'd been looking forward to that day where we played frisbee, ultimate frisbee, and frisbee golf. Another day was just helping family with something that was unexpected. Another day I deliberately took off because AI told me, literally told me that I was working too much and I needed a mental break. But when AI saw the dip in the data, it didn't know why the dip was there and it didn't have enough context. So instead of blindly accepting those recommendations, what I did was I looked at that and I was like, this doesn't make sense because I wasn't feeling that way. But this is before I actually understood what the data was what AI was pulling from. I went through the analysis like like a normal data analyst, and I looked at all the trends in the numbers line by line, section by section, to see why it was coming to those conclusions. I had AI map me out its reasoning and walk me through why it was making the recommendations so I could audit its thought process. And that's when I found the places it was misattributing those trends. This is the classic mistake that people make, where it's classic correlation does not create causation. Because when things happen together, it doesn't mean that they cause one another. You have to add in the context. And one of the favorite studies that I remember from, I think it was from college, was there was researchers researching sleep quality, and then they attributed that sleeping with your shoes in your bed led to worse sleep quality. But it was because they were studying college students, and the college students who got drunk and partied the night before ended up sleeping with their shoes. And then because it was a variable that they were tracking, they assumed that it was the shoes that was creating the worst sleep quality, but it wasn't the shoes. It was getting drunk and partying the whole night before. So, not just regular data, it's understanding that you need to dive into it deeper and give it enough context and understand what is going on, because I caught it because I lived those days. I knew the context. And if I had just accepted that output, I would have restructured my entire schedule around patterns that didn't actually exist. So that is a representation that the job doesn't just get automated. There's going to be analysis that needs to be done on the AI output, not just running the analysis, but knowing when the analysis is wrong. And this is already changing what the day to day looks like. So let's go 2 years ago. This is when I first found ChatGPT. So before that, and then to now. 2 years ago, I was writing code mostly myself, writing code, building from scratch, manual research, and then generally doing the execution. Now I'm doing a lot more designing. So I'm doing a lot more technical structures, architecture, designing the technical specs in a way that is a lot more complex than I was previously doing so that I can better direct AI, and also that AI has enough context to keep working. And then now, I've been using AI more to build the base, because there's going to be tasks where it can get me. A lot of what I ran into previously was a blank page, the where you are so paralyzed by all of the options of how to build something that you don't really start, and then you have to wait and you procrastinate. And then once a project's due, that's when you have the motivation to actually build it. Now I can use AI to build the base and get me there faster, and then I build off of the base. So one of the biggest issues that I ran into previously with just like a blank screen and just starting, it helps me start. I get to build the momentum, and then I add the complexity on top of that. And then now I was always doing this validation part, but now I'm having AI help me build the validations. And now I have to be able to validate and test the output more. And then in general, what I'm doing less execution, and now I'm doing a lot more architecting, designing, systems designing. So 2 years ago, I was writing most of the code myself, or just doing the old school way. When I didn't know what to do, it was just go to Stack Overflow, look at all of the different things, start putting things together, understand like the code base, and then iterate, fail, fail, fail until you figure it out and it starts to work. That was the old school way of doing things. And then I was also building from scratch. So think of Excel models, building those from complete scratch. And then doing tedious research manually, looking at a bunch of websites, pulling the research, printing them out, highlighting them, putting them in the Word docs, however, whatever the process was at that time, I was doing. And so that's the execution. Writing significantly less code myself. I'm outputting significantly more code and higher quality code because of AI. I spend more time designing systems, architecting solutions, and directing AI on what to build than validating and testing what it gives me. I'm comfortable with AI writing the code because what the biggest thing that I care about now is the building part. Because when AI writes the code, it's deterministic. As long as it works and as long as the design makes sense, and because the AI models are at a human expert level benchmarks, and we see full dark factories of major tech companies where their AI agents are building all of the code now, and their engineers aren't building any code currently. So that's where we have to build up to. I'm directing AI on what to build, and I'm validating and testing what it gives me. And what I care about is, like I said, building the building part, the design, and getting it to work, then adding the enhancements, making sure that it delivers the value to users. And with AI, I get to do that faster in more languages than I ever could on my own. And that's the shift. Less execution, more judgment, more architecture, and more does this actually make sense for the business? And me becoming a more generalist in terms of understanding JavaScript, Python, web architecture, security, network, in the ways that I need it enough to pull the best output of from the AI LLM models and all the different AI harnesses that we're using currently. And for me, that's the exciting part because I love learning and I get to learn more broad skill set across all of tech. And that is the exciting part. And the people I see who are thriving right now, they see AI as a tool that makes them faster, more productive, not a threat, not a replacement, but just a tool. And overheard someone say recently that AI was just an over glorified Google search. And I get how someone could think that if they haven't gone deep into using AI. But it also tells me they haven't truly explored AI and what it's actually powerful and what is actually possible. They haven't built workflows around it. They haven't experienced how the improvements compound on each other and how you can grow your knowledge base and you as a person learning with AI significantly faster, because that compounding is the part that most people miss. Because every week that you get better with AI, your output improves, your AI improves too, and your ability to leverage it compounds on top of that. So you can think about this as compound interest in finance, but it's compound growth in you getting better. And now that's the uncomfortable truth that I don't see more people talking about, is that if you're learning to wait to learn AI until you learn data analytics, you're building a gap that's going to be harder to close later. Because the people who are learning both at the same time are the ones who are compounding that advantage now. Yes, it's going to be more complex. Yes, it's different. And there's not as many people talking about it, but the window is open if you're willing to step into the mess and allow things to be messy and figure it out as you go. But it's not, your competitive advantage is not going to stay open forever, because Google just made AI 6 times faster to run. That means more companies are going to be deploying AI, more projects are going to be moving from pilot to production, and there's going to be more demand for people who can work with AI output and know when to trust it and when to push back. So that's not a threat to your career, that's your opportunity. And if you want to keep up to date and learn how to break into healthcare analytics and learn how to learn AI to evolve with the market and build that advantage now, that is what the Healthcare Analyst Lab is for. And it's a community that I'm building. Link is in the description below. Check it out if it makes sense. Watch this next video because YouTube thinks that you're going to like it. Query responsibly. And if you have any questions, comments, or anything you want me to cover in the future, leave a comment below and I'll cover that. And until then, I'll see you in the next video and query responsibly and watch the next video now.